Now this operation right here is known as a rank-1 update. And more abstractly, we can say this is a vector x times a row vector y being added to a matrix A. Now let's think about how this works. This here you recognize as an outer product. And an outer product just computes the matrix, well, this particular outer product computes the matrix where the first element is 2 times minus 2. And then the second element is 2 times 0. And the third element is 2 times 1, and so forth. The second row becomes minus 1 times minus 2, minus 1 times 0, minus 1 times 1, and then finally 0 times minus 2, 0 times 0, and 0 times 1. Okay? But notice that here we're actually adding to a matrix. And it's called a rank-1 update because an outer product has rank of at most 1, and you're updating a matrix with it. So if you take what we computed right here, which is the result of doing this operation, and you recognize that it needs to be added to matrix A, then what you get is this right here. 2 times minus 1 plus 2, 2 times 0 plus 2, 2 times 1 minus 1, and then minus 1 times minus 2 plus 2, and so forth. Okay? Now, if you look at this right here, what you recognize is that that's really just this particular vector, which happens to be the vector that we started with right here, x, times minus 2. So you can also think of this as 2 minus 1, 0, multiplied by the scalar minus 2, and adding that particular result to the first column of matrix A. And then you can do the same thing for this right here, and lo and behold, you get that same vector, now times 0, added to the second column of A. And hopefully you're starting to see a pattern here. Now, somewhere in linear algebra you learned that a vector times a scalar is the same as a scalar times a vector. So now we can switch these two around, and you get minus 2 times 2 minus 1, 0, added to the first column of matrix A, and then 0 times 2 minus 1, 0, added to the second column of A, and then 1 times 2 minus 1, 0, added to the last column of A. So hopefully you see a pattern here. When you do an outer product added to a matrix, a rank-1 update, what you really are doing is an XP where the scalar comes from the entry in Y transpose, the first entry, times the vector x, added to the first column of A. Then an XP where you do the scalar, which is the second element in Y transpose, times the vector x, 2 minus 1, 0, added to the second column of A. And then finally, the last scalar in Y transpose, multiplied times the vector x, added to the last column of A. And you really should be able to go directly from here to there.